Hi, welcome to Such a Study Tech. Today topic is the traveling salesperson problem by using dynamic programming approach. A tour of G, that is graph, is a directed simple cycle that includes every vertex in V. The traveling salesperson problem is to find a tour of a minimum cost. So this is the minimization problem. You can find out the minimum path. So if you can use the dynamic programming approach, you can take the sequence of decisions. Where you can take the sequence of decisions, for example, you can start with vertex 1 city, then okay, you can go to city 2 or city 3 or city 4, which are the distance is small, you can go that, you can explore that node. So that's why you can use the dynamic programming approach. Here it is a time complexity exploring all permutations is big of n factorial, that is the time complexity of the traveling salesperson problem, and big of n space complexity using recursion. Here it is the time complexity is big of n factorial and big of n for the space complexity. Now using the top down approach by using dynamic programming memoization technique, here it is the time complexity is big of n square into 2 power n. Space complexity is big of n square n into 2 power n. This is the space complexity. Here it is big of n into 2 power n. This is the space complexity. Here it is big of n square into 2 power n. So now we can discuss one example problem. You can see this is here either it is a directed or undirected graph. Here it is a undirected graph. Here what is undirected graph? You know already undirected graph means either 1 to 2 the cost of the edge is 4. Here 2 to 1 is cost is also 4. So this is an undirected graph. But here you can see here 1 to 2 it is 4 and 2 to 1 is also 4 because it is a undirected graph. Sometimes it can given like this. Here it is bidirectional, here 1 to 2 and 2 to 1, so that here it is for example 1 to 2 is, it cannot mention here it is 1 or 2, 1 to 2 is 4 and 2 to 1 may be 3, okay, different value. So here it is bidirectional, 1 to 2 is 4 and 2 to 1 is 3, okay, in bidirectional graph. But here it is a undirected graph. Here it is undirected graph, so that 1 to 2 is 4 and 2 to 1 is also 4. Maybe any values what are the graph is there, okay, this graph is converted into the matrix format. Then 1 to 2 is 4 and 2 to 1 is 4, like that. Here 1 to 1 is 0, the distance between 1 to 1 is 0, 2 to is 0, 3 to 0, 4 4 0, like that. Here it is 1 to 4 is 3, like here 1 to 4 is 3 and 1 to 3 is 1, like that. You can write the matrix. Then this is the formula g of I g comma g of I comma s equal to minimum of c I k plus g of k comma s minus k. So here it is, I am considered this is the one is the source vertex. Here the traveling salesperson problem starting in this vertex, in this node you can travel all other vertices, you can travel all other vertices and back to the initial vertex. So it can take whichever the tour is, take the minimum, that is you can consider, that is the minimum tour. How to find out? Now you can see here it is, for example here the traveling salesperson problem starting in the vertex 1. Here it is, go to the vertex 2, here vertex 2, here it is vertex 3, here it is vertex 4. Now 1 to 2 2, here it is, you can see here g of, so you can use this formula here 1 comma 2, here it is, for example I am considered 1, remaining set is remaining s is the remaining set, that is the nodes are 2 comma 3 comma 4, okay. So here it is, you can consider 1 to 2, you can write better, you can write here it is g of one come, for example, one is the initial source vertex here, the traveling salesperson starting in this vertex, and remaining vertices are, S means remaining vertices, unvisited vertices, that is 2 comma 3 comma 4, that is equal to minimum of Cik. For example, I value is 1 here, k is, you can consider the next vertex 1 comma 2, then S minus k, so S is, so you can subtract 2 here, then remaining vertices are 3 4, like here C of, here you can see C of Ik, that is 1 2 plus G of here you can consider the vertex is to this node, and remaining vertices are 3 comma 4, remaining vertices are 3 comma 4 here. Like that, here it is C of 1 comma 3 plus G of, you can call recursive function here, G of, here it is, for example, you can consider the 1 2 3, then remaining vertices are here it is 1 comma 3, then remaining vertices are 2 comma 4, like that. Here it is C of 1 comma 4 plus G of, okay, you can consider the fourth one here, then remaining vertices are 2 comma 3. So here you can see it, you know already C of 1 2, so C of 1 2 value is 4, C of 1 2 value is for example here it is 4, but you don't know G of 2 comma 3 comma 4. Now here expand this, you can expand this, here it is, I am consider 2 2 3 here, vertex 3, then here it is C of 2 comma 3 here, plus remaining vertices are fourth vertex, here you can consider the 3, G of 3 comma remaining vertex are 4, like that. Here also, for example, here at vertex 2 2 3, here it is maybe 2 2 4, here also C of 2 comma 4 plus G of 1 2 4 is over. Now here consider the fourth vertex, then remaining vertex is 3, like that. Here also you can expand this node, here it is C of 3 comma 2 plus G of you can consider the vertex 2, here the remaining vertices are 4, here you can see C of then 3 comma, for example here it is 3 to 2, here it is 3 to 4, like here it is C of 3 comma 4 plus G of here consider the fourth vertex, here the remaining vertices are, here you can consider the fourth vertex 1 3 4, remaining vertices are 2. So like that, here expand this, for example here it is vertex 2, here is vertex 3, so C of here fourth vertex 2 4 to 2 plus G of here you can consider the 2, then remaining vertices are 3, here also C of 4 to 3 plus G of, here consider the third vertex, then remaining vertices are second one, like you can expand this, you know already C of 2 3, C of 2 3 value is 2, so it is 2. Now here you can expand this. Here it is 4. Okay, only one remaining vertex, unvisited vertex is there. Here it is 4. That is C of 3 to 4. C of 3 to 4 plus G of, here you can see here it is G of, for example, 4 to pi. That means here 1 to 2 and 2 to 3 and 3 to 4, then 2 is completed, then 4 to 1. So you can reach the initial vertex, initial city, where you can started that traveling salesperson problem. You can reach after visiting all vertices, you can reach to the starting vertex. That's why here 4 to pi, that value is here 4 to 1, that is 3. You can note down here. And G of, for example, 3 to pi, that value is 3 to 1 is 1. You can note down here. C of 2 comma pi, that is equal to 2 to 1. Here the cost is 4. Like that, here it is, for example, G of 1 comma pi, that value is 0. Already this is the starting city, starting vertex. So that here it is 4 of pi. Here the 4 of pi, you can note down, here it is. Like that, you can see here it is. You can reach to 3. That means C of 4 3 plus G of here 3 comma pi. You can reach to the starting vertex. Here also you can see, here it is 4, that is 2 to 4, C of 2 to 4 plus G of 4 comma pi. And also here also the remaining unvisited vertex is 2, so that is 4 to 2, 4 to 2 plus here it is 2, vertex 2, 4 to 2 plus G of 2 comma pi. Like that, here also have the 3, vertex 3, and C of 2 to 3, 2 to 3 plus G of 3 to pi, 3 to pi. Here also you can see unvisited vertex is 2, that is 2 here, and 3 to 2, C of 3 to 2, the cost of C of 3 to 2 is plus G of 2 comma pi. So you can see here C of 3 4, C of 3 4 value you can see in this matrix, 3 4 value is 5. Here it is 5 plus G of 4 pi. Here you can see it is 3. 5 plus 3, it is 8. So this value is 8. This value is 8. C of 2 3, 2 3 value is 2. So that value is 10. You can note down here. 2 plus 8, it is 10. Now 4 4 3, here it is 5. It is 5. C of 4 3 is 5. And G of 3 pi, that value is 1. So 5 plus 1, that is 6. So here it is 6 plus C of 2 4 here. C of 2 4, 2 4 value is 1. 1 plus 6, that is 7. You can note down here. It is 10, it is 7. Like you can see here it is. Here already value is 4. Now whichever the minimum, here you can consider whichever the minimum here, 10 or 7. 10 is the minimum. So you can consider the 7 here. You can consider the 7. That is the minimum. This is the minimum. You can consider this one. Then here it is 4 plus 7, that is 11. Note down here. Like that, here C of 2 4. C of 2 4 value is 1 plus G of 4 5, that is 3. That is equal to 4. C of 3 2. C of 3 2 value is 2. Here it is 2. Then this value is 4. 2 plus 4, that value is 6 here. You can note down. So you can see here it is C of 4 2, 4 2 value is 1 plus G of 2 5, 2 5 value is 4. So 1 plus 4, that is 5. Here it is 5. So this value is 5. Now C of 3 4, C of 3 4 value is 5. Here also 3 4 value is 5. 5 plus 5, that is 10. Which is the minimum? Here you can see this is the minimum. So you can consider that one. And C of 1 3, C of 1 3 value is 1. So 1 plus 6 is 7. Now like that, here also you can see C of 2 3, 2 3 value is 2 plus 3 5, that is 1. 2 plus 1, that is 3. Here it is 3. So C of 4 2, C of 4 2 value is 1. So 1 plus 3, that is 4 here. Here you can see C of 3 2, 3 2 value is 2. It is 2 plus 2 of 5, 2 of 5 value is 4. It is 6. Okay, this value is 6. So C of 4 3. So what is the C of 4 3 value? 4 3 value is 5. Here it is 5. 5 plus 6, that is 11. You can note down here. So which is the minimum here? 4 is the minimum. So here C of 1 4 is, C of 1 4 is 3. So 3 plus 4, that is 7. You can note down here. You can note down here. It is 7. Here also 7. You can see here it is. Then, so which is the minimum among these three? So here it is 7. Here is also 7. So 7 is the minimum. So the minimum tour is 7. Here it is. Either it is, you can check 1 2 3, 1 2 3. I can write here 1 2 3. It is 1. Next, here it is consider which is the minimum. Here is this is the minimum. So 2 2 4 and 2 2 4 here, and 3 2 2, 3 2 2 is 2, and 2 2 4, 2 2 4 is 1, and 4 2 1, 4 2 1, that value is 3. So you can see 4 plus 3, 7. This is 7. Okay. Now you can check in this case also. This is one tour. Another you can check 1 2 4, 1 2 4, and which is the minimum among these? Here it is. Here it is 4 plus 11. Here the 4 is the minimum. So 4 to 2, 4 to 2, and 4 to 2, and 2 to 3, 2 to 3, and 3 to 1. Now you can see 1 to 4, 1 to 4 value is 3, and 4 to 2, 4 to 2 value is 1, and 2 to 3, 2 to 3 value is 2. Here 3 to 1, that value is 1. Now you can see 3 plus 1, 4 plus 2, 6 plus 1, 7. This is also a 7. This is another tour. So this is one tour, two tours. Here these two are equal. So minimum path is, it is 7. So either it is 1 4 2 3 and 1, and 1 3 2 4 to 1. So these are the two tours. So these are the minimum. So it is minimum tour is 7. Thank you for watching this video.